Welcome to episode 24 of writing a 6502 assembler in a similar language. I'm just going to pick up right where I left off in the last episode, and that is looking at error handling. In this case, we're talking about the parser, and there's actually very little to do here, so we can move past this quickly, I believe. So we're going to search for errors. Okay, here we call error with an unexpected token message. And that needs to be a JSR. Now we just see how do we get here. Okay, here's where we are restoring a 0-page pointer from the stack. We're calling scan to get a token. If it's end of statement, then we return. If it is a comma, then we return. If it's something else, end of file, then we unscan that return. If it's something else, then we say unexpected token. So the situation here is that a line is composed of, or I should say, our source file is composed of a sequence of labeled statements. In other words, 0 or more labels followed by a statement repeated indefinitely, theoretically. And so when we get to what looks like the end of a statement, we expect to see something which is the end of a statement. We see a token end of statement, which is actually a new line. Or we see a comma, which then allows us to give another statement. Or we see it in the file. Those are all fine, because up until this point, we've seen a complete, entire, well-formed statement. So then we have to have an end of statement marker, which can be new line, comma, or in a file. If we don't see one of those, we get some other token, then the token is unexpected. It doesn't fit in our grammar. Okay? So how do we handle this error? What we should do in this case is probably just collect tokens. We got a complete syntactically correct statement. We should have something to separate statements, that is a new line, comma, or in the file, which doesn't separate, but it's a valid ending for a statement. But we didn't get that. We got some other token. Well, one thing we could do is just pretend that we did get an end of statement. Some statement separator. Of course, we should still generate an error, but that might be good in the sense that, like, if someone did something like this, load a 0, and then suppose they wanted to, now I don't think this is good practice, but suppose they wanted to just put another thing like here, they wanted to put another, instruction on the same line as this for some reason. Like this, and they even put a label on it or something like that. So this doesn't seem like a good idea to me from a point of view of making readable code, but the assembler would allow it. Right? They intended to do this, but instead they just did this, or even this. Right? This would be correct, but they did this. Right? Maybe maybe they, who knows? They're trying to write obfuscated assembler. They're trying to write this. They forgot the comma. Right? Well then, we should generate an error, but on the other hand, why not go ahead and try to power through it? Maybe, this is okay. even more, if they put a label here like this would be correct. If the thing is, if we say, hey, they didn't put a comma, and so let's freak out and start deleting input, then what's going to happen is this label will not be defined. And that will cause cascading errors all the way down the line whenever it's some other place you have a B and E foo. So I think probably what we ought to do is, if we didn't get a statement separator, we should just say, okay, generate an error, but then we're just going to pretend that we did get a statement separator. And there we go. We'll pretend we did get a statement separator and just continue to try to parse statements, because it's probably some sort of error like I just showed, where the user wanted to put multiple statements online but just forgot the comma or whatever. So we'll try to deal with it. We'll try to continue. I think that's the best thing to handle, the best thing to do, because, like I said, that means if it is an error like I just showed, where the user just forgot to put a comma, then we won't lose labels and stuff like that. Of course, it could be that afterwards is total nonsense, right? That the input is more like this, and then whatever. In that case, we're going to throw all sorts of errors on this other stuff, but that's what the user deserves in that case. So, unexpected token. But let's go ahead and keep trying to do it. So that means what we'll want to do is we'll want to unget the bad token, unget the unexpected token, I should say. Okay. I'm just thinking, can we combine these two here? Probably not, because otherwise I would have to do the unscan here, but unscanning could very well destroy the value of A. Well, it probably doesn't, does it, actually, because it just stores the value of A somewhere. Well, any case, I don't want to go look at it, and I also don't want to make this code dependent on whether or not unscan destroys the value of A or not, because then maybe it'll change in the future if I go back and work on unscan. Looks like there was an error here anyway, right? If it's TOF, yeah, before I changed it just now, I just added this, right? Before I changed it, it was just like that. So into file, yeah, I think that was just wrong anyway. Okay, compare into file. Branch if branch if not equal to end of file to statement 9b. Start this statement 9b. Error, JSR error. That can go away. Okay. So after getting a valid statement, we look for a token to make sure it's an end of statement, something which separates statements. End of statement, all good. Go to 9b and return. Colon, all good. Go to 9b, return. If it's not an end of file, then go down here. If it is an end of file, unscan the end of file and return. Yeah, I'm actually not 100% sure if we have to unscan the end of file, and the reason being is that in Unix you can just get an infinite number of end of files out of getc, and I'm pretty sure that my getc does that too, but I'm gonna unscan it just for safety's sake right now because I'm not 100% sure. Unscan the end of file and return. If we did not get something which says separate statements, then we're going to print our unexpected token. Actually, the first thing we need to do is unscan the token. Print the thing and then return. So in other words, we're going to unscan the token. I really don't like having this twice. But on the other hand, it's not that big a deal, is it? I mean, I could push it. JRSR unscan. Right? Pull it back, compare with end of file. If it's not end of file, go down here. Now I don't need to unscan. Just the point being is that if the token that we get is a new line or a comma, we don't need to unscan it. We'll just consume those. Otherwise, we need to unscan it no matter what it is. So I push A, unscan, pull A just to be able to do this with knowing that A is okay. And if it's an actual end of file, if it's not end of file, then it's an error. We print out the error, but we're going to go ahead and return. Otherwise, we return. And so what will happen is that if we get some sort of token at the end of a statement, which is not a statement separator, it'll print out this error message, but then it will go ahead and try to take that input, which is after the syntactically correct statement, and try to build another statement. All right. This is to do syntax error. That's right where we get something which doesn't look like part of an expression. And this is where our stack blows up because our expression is too complex. And in this case, basically we've blown out our stack because our expression is too complex. In this case, what we need to do is we need to back out of the entire thing and return a 0 for the expression value, right? Or it doesn't even matter. We're going to return something for the expression value. We're going to print the error, but actually return a value for the expression value. And yeah, there's some to-dos here. Oh, we also have to go back and look at that forward label, backward label stuff from last time. That's something else. Like here, for example, right? When it sees a forward label, backward label, it needs to make sure that the value of that forward label or backward label is less than 10. If it's not, it's an undefined label. So that ties into this looking for undefined labels here. Okay, and I can put this here. To do, make sure less than 10. To do, make sure less than 10. So there's a good bit of little work here to do to handle errors and whatnot, but for the moment, we need to handle this situation. Okay, and this we get here from term x8. We're checking the stack here. If it's less than 32, we're going to go down and say our stack has exploded. That is, we have less than 32 bytes left on the stack. We'll say our stack has exploded and we can't continue. Our expression is too complex. Because we're just using the hardware stack here. I mean, of course, we could always allocate a bigger area to use for a stack to handle expressions, but for the moment, using the hardware stack seems fine. It'll probably work. I don't really expect there to be a real issue. And we go to term x5, I believe, when we get a left parenthesis. Indeed. Left parenthesis goes to term x5, and that's when we're going to push all this stuff on the stack. So we have to check and make sure that we have space on the stack. And yeah, if we do have space down here, we're going to push a bunch of junk on the stack. Right? This is for our recursive call. So if we don't have space in the stack, we'll come down here. All right, so what we need to do though is that the expression parser needs to, because this is going to happen when we're deep in recursion. Like, you're 5-6 levels of recursion in on this thing, which means that your expression has, like multiple etc. I mean, like, this is 3 levels. It's got to be like 5 or 6 levels for the stack to blow out. Right? So what we're going to have to do is when we enter the expression parser, we're going to have to record the stack pointer. And at this point, we're going to have to print our error out, expression too complex, then restore the stack pointer and return as if we got a good expression, only the expression is, because I got a value of 0. But wait a minute, actually that's not quite right. We don't want to stop in the middle of parsing, because maybe the expression is perfectly syntactically valid. It's just it's too complex. We've blown out the stack. What do we do? What do we do? Because actually, yeah, we would like to continue parsing. Suppose the programmer wrote an expression which has 10 levels of nested parentheses. We're going to blow out the stack. But there's no reason we can't look at the whole thing and say, yeah, it's syntactically valid. We don't know what its value is because we can't evaluate it. That might require a little bit of work, but it seems to me to be the right thing to do. Right? If you blow out the stack somehow, well, I'm just thinking if you're blowing out the stack, you'd say, okay, we're going to go back and fix things up so we're not actually storing all the values of these intermediate variables in the stack, because we're going to return 0 in the end anyway for the value of the expression. But if you still have just return addresses on the stack, someone could theoretically destroy the whole thing by, putting, making it, 100 nested parentheses or 200 nested parentheses, right? In that case, even if you were not storing anything at all on the stack except for just the return addresses, you'd end up blowing out the stack. So I'm thinking the thing to do is, since this is only an issue with nested parentheses, that's the only thing which causes this data to get put in the stack, apart from the return addresses themselves. What probably maybe would be a good idea to do would have some sort of error recovery that counts parentheses. So as we go into the, right, every time we get a left parenthesis, you're going another level of recursion deeper in terms of the variables. You're going, another level of recursion deeper in terms of return addresses every time you use a different production of the grammar. Hang on, I'll show you what I mean by that. I hope this is the right thing. It's not. So hang on a sec. Okay, here's the right thing. So as far as the recursion, the return addresses in the stack, each of these productions basically means another subroutine which is called. Like expr, or exp, and exp, sum exp, mul exp, unary exp, and so on. Term exp. These, you get another return address every time you go in there. But that's a limited amount. Unless you have a parenthesis in your expression, you're not going to start over at the top. The starting over the top comes, you start here and you go into or exp calls and exp calls sum exp calls mul exp calls unary exp calls term exp, and then term exp here gets a left parenthesis and goes back and calls or exp again. Without the left parenthesis, you don't have to worry about that. You're at the bottom of you're not going to go any further down this chain. There's nowhere further to go. So only when you have the left parenthesis do you have to really care about blowing out the stack and having too much recursion, too many function calls. So I think, just count the number of left and right parentheses. And then what you can do is if you so counting the number of left and right parentheses means counting how deep you are in the recursion. So we probably want here, I see, I've already stored, I've already stored the expr stack. I've already done that part. Right, that makes sense. Of course, I've already done that. The stack pointer, when you call the expression parser, is saved, and if you blow out the stack, you restore it and return. The problem with this is that I'm returning in the middle of an expression, so what's going to happen? Well, the way it used to work is error would clear everything to the end of line, but it doesn't do that now. So now what's going to happen is that you're going to start trying to parse in the middle of an expression, which is not going to work. So instead, we probably want here to have I'll call it reclev. This is recursion levels. And every time we get this parenthesis here, okay, we're going to jump to term exp5. And that's going to check the stack to see if we're blowing something out. Okay. Yeah, I think I should, it's before that, I should inc rec level to increment the recursion level. Well, it's really, maybe I shouldn't call it recursion level because it's only the recursion level if we don't blow out the stack. Right? Let me just call it nl paren. It's the number of left parens. That's better. So increment the number of left parens. All right. Then check to see if the stack's blown out. If it's not, we're all good. If it is, maybe I won't even call it L paren, but just paren. Number paren. Okay, number of parens. Let me just go ahead and change that here. Okay. Right. And here's where we need to decrement in parens. Right? Because we increment when we see the left parenthesis, and we decrement when we see the right parenthesis. Now, at this point, we're going to, okay, the stack's been blown out. We're too deep. We can't do another level of recursion, right? So we say, okay, restore our old stack, print out the error message, expression too complex. But now what we need to do really is we need to get tokens I'll just call it term X. Okay. We need to get tokens until the number paren variable is 0, or until we get, you know, something which ends the expression anyway, like a new line or whatever. Yeah, expressions cannot cross new lines. Yeah, that is correct, because the new line is a statement separator. Okay. But we are going to have to check for it, right? So we're going to scan, and if we get a left parenthesis, okay, and I should maybe make a new label kind of thing here. This is going to be the top of the loop. So we'll call this it's about the expression. All we want to do is scan till we finish this. Ooh. Yeah. I'm just thinking, if we scan till we get a right parenthesis, that's not necessarily the end of the expression. Right? That's not necessarily the end of the expression. So this part right here is maybe not exactly what we want to do. Let's just say fix exp1 here. I'll call it fix exp0. All right, so we're going to increment in paren if it is exp1 comp right parenthesis fix exp2. Now we'll call this to dec and paren, and now we have to think of the possibility if we, you know, something which should end the statement. So a comma is not a valid part of an expression. It's the end of a statement. Okay. Also a new line. Okay. And as far as end of files, what do we see up here? There's yeah, I don't think end of file comes back as a token, does it? That's a good question. Let's oh, it does. TEOF. Okay. What am I doing? Stop that. Here we go. Okay. TEOF branch if not equal to fix x0. So just fix x3. So the idea of this whole fix x code is to find the end of the expression. We're just collecting tokens. We're not actually trying to understand the expression at all. We're just collecting the expression. We can't try to understand it because we've blown out the stack. Just trying to find the end of the expression. So we're going to do that by counting parentheses. Okay, and that means we have something to do right here. Counting parentheses. Otherwise, just collecting tokens. If we happen to get something which is the end of line or whatever, then that means the expression's definitely over. Okay, so if the expression, okay, so first off, if we get here in paren and we're down to that's a good question. What should we be looking for it to be 0? Well, if we look for it to be 0, okay, the very first time, wait, where is this X per stack done? The very first time that we get a left parenthesis is when imprint is incremented off 0. So that means if we decrement imprint, it gets to 0, we've matched that very first left parenthesis. However, that very first left parenthesis and now the right parenthesis which matches it are just a sub-expression of the entire expression. So really, I'm thinking that entire sub-expression, which was that's the part which was too complex to evaluate. We set that whole thing to 0. I'm thinking that this probably should not print this error here right now. Instead, we should probably do something like here. Too complex. And we call this place, we're going to this place, the place that's actually too complex. And term x8, sorry, 8, increment too complex. So this will be set to 0 when we start evaluating an expression. Okay, and I can actually do that now. Yeah, here's where we set this stack. I'm not sure that's going to stay the same way, but we'll see. We need to load 0. Whoops, not 1, 0. Store that in too complex. So in other words, we're saying it's not too complex right now. Okay, we're going to increment now to say, yes, it is too complex. Okay, so we're not going to print this error at the moment. And I don't know that we necessarily want to do this at the moment. Okay. And maybe, so up here, we got a left parenthesis. We're going to increment num_parens, and then check the stack. If the stack gets blown up, we go down there. Otherwise, we do this. Maybe instead, we should increment num_parens here. That is, we don't do increment num_parens. Or maybe not. I'm just thinking. The idea is what I'm thinking here is that I want this entire sub-expression, which is too complex, to be ignored. Okay? This entire sub-expression, which is too complex, needs to be ignored. So suppose that number of parens is 5. And now we get a 6th, which is going to cause us to blow up the stack. A 6th. We found 5 left parentheses, and we haven't closed them out. We have 5 open left parentheses. We get a 6th, which is now going to cause the stack to blow out. That means, and then we could theoretically get more. We could get 7, 8, 9 or whatever before we actually start closing some of these parentheses out. What it means is that if it was 5, and then this is going to make it 6, yeah, no. Okay, go ahead and increment it. Check the stack. So now it's 6. Now this sub-expression is finished when the number of parentheses goes down to 5, because that's what it was right before we entered here. Right? So actually, yes, I think we should do it like this. Okay, so when we get a left parenthesis, we go here, we check see if we're going to blow the stack out. If we do, If we are going to blow the stack out, then we go down here. It allows me to increment the number of parens and continue. All right, if we get down here, I think what we want to do, we're going to increment to complex to say, yes, we have a problem here. And now what we want to do perhaps is take the number of parens that we have here, and we can store that in someplace, bar plus 1. Okay, and now we're going to go ahead and increment the number of parens because we did get one, right? But we want to take the number that before we increment it. Okay, we increment the number of parens, so now we have our sixth left paren, which is a stack blowout situation. Then we're going to start scanning. Okay, if we get a left parenthesis, we're going to increment the number of parens again. Is num parens, right? It is. Okay. If we get a right parenthesis, we're going to decrement the number of parens. If we get some statement separator, we're going to handle that. If not, we go up and scan some more tokens up to here. Now what we're going to do is, if we decrement the number of parens, 4, for example, we're going to compare that number of parens here. Zero. Okay, so instead of foo, it's fix x, bar here, it's fix exp 4 plus 1. So if we get a 2x complex expression, we're going to take the number of parens that we have before it gets too complex, store it here, then increment the number of parens because we got one, which is why we're here in the first place. We got one too many. Then we're going to start scanning. And when we get enough right parens to decrement this down so that we're back to the level we were at before, that is the non-blow out the stack level, right? Then we can be done. At this point, we can be done with our code that avoids the stack blowout, and we can continue parsing the expression. We should set the expression to a certain value. It's okay. If it's a number, then go to term exp1. So we just store an expr value and expr type 1. So we'll basically just do this. Okay. We can put a 0 in tokeval and then jump here and return that. Okay, if the number of parens is not the same. Oh, yeah, actually, this has to go scan more stuff also. So this is inc num parens. I'm trying to go to fix exp 0. Okay, if it's not equal to 0, I mean, if it's not equal, not to 0, but if the number of parens is not equal to the number we're looking for, we'll go back up to fix exp 0 to scan some more. Okay. If it is equal, then we can load 0. And we have to do this because this is not necessarily 0 right here, actually. It's going to get stored. It's whatever is stored right here. Okay, store that in Tocqueville. Store it in Tocqueville +1. And can we, is it close enough to branch? Probably not. We have to jump up to term exp1. Okay, so what it will do is it will return a 0 for this sub expression as if it were just a number 0, but we can keep parsing. And of course, maybe you have another sub expression that puts you past the limit. That would do the same thing. It would try to skip over it, but it's not going to print a message because we're not printing a message right now. It'll print only one message in the end. Okay, so here's the situation where we get an end of statement and we haven't gotten, so this is going to be a syntax error of a different type. This is a case where you don't have a complete expression syntactically, but you've got now the end of line, comma, something which is no good. This is just the sort of generic syntax error situation here. Okay, and so that actually going to be the same issue as this right here. It's just a syntax error. So we could just jump to term exp0. And I think that will be fine. Right? We're not using this at the moment, this saved stack pointer right here, because this code is not trying to restore the stack to what it was when the expression parser was called. Instead, we're just trying to skip over the problematic parts of the expression. And if we can do that successfully, we can keep parsing the expression, all the parts that don't blow out the stack. Okay, and if we get some sort of new line or end of file or whatever in the middle, that's just a plain old syntax error. So we can jump up to term exp0, which handles plain old syntax errors. Okay. So that all looks good. So now we, when we finish the entire expression, when we've done the whole thing, we need to check this here. And we can call that. And I don't think we need this anymore. That can go away. CPLX error. Okay. So go down and find that. Here we go. Like I said, I don't think we need to do this part now. But we're going to call this. And now we're going to check okay. CPLX error, JSR error. Okay, so we'll print out the message here. That expression was too complex. and then just continue. Yeah, I'm a dumbass, as always. I'm a dumbass. Okay. TSX store x for stack. We do need this because we need this for the case of the generic syntax error. Or at least in the case of the unfinished expression, because right in the middle of the expression we get an unexpected new line or something like that. Yeah, that actually is a little bit different than just from a regular syntax error, isn't it? So maybe this is not the right thing to do here. Maybe here, actually, this is the situation where we get a new line in the middle of our expression parse. I mean, in the middle of our expression parse after we found a too complex expression. And so in this case, I think we really do need to x per stack. Okay, and the thing is, xper stack is a stack pointer after xper has been called, but before or xper has been called. I would actually prefer to have not this stack, but one which is 2 lower. Okay, so what I'm doing here is I'm taking the stack pointer. Now this stack pointer, when xper stack was saved, the stack pointer is pointing at the return address when xper is called. So it will point back at whoever called xper. Instead, I want to decrement the stack pointer twice, and this should give me the stack pointer, the address inside xper stack, inside the xper routine. It should, when I do an RTS here, it should return to the xper stack function itself because of these two decrements right here. Right? Because when xper stack calls or xper, it pushes the address onto the stack, which will decrement the stack pointer by 2. So I get the saved stack pointer, decrement that by 2, and that should mean I'm now pointing at the return address inside the xper subroutine where it calls or xper. If I put that in the stack and return, then I should return to that location. And that location come on, or exp. Here it is. Yes, that is right here. So it should return immediately here. If it did that, it would print expression too complex and then return, which would be fair because the expression is too complex. It's also an error because it has a new line or whatever in the middle of it, but it's, I mean, syntactically invalid, but it's also too complex. And that will return. Is that what I want? Is it okay? The alternative is to have it print out another message which basically says syntax error or unexpected end of line in expression or something like that, and then return without saying it's too complex. Or should it print both errors, unexpected end of line and expression too complex? That's a good question. Maybe it should print both errors. I'm thinking of an error here along the lines of, and I'm going to have this somewhere else too, I imagine, right? Of, hey, I'm trying to get an expression. I have suddenly a new line that I shouldn't have, right? Like, even if there's not too complex, if I have an expression like this, new line, right? That's got to be an error. So whether it's the expression is too complex or not, this is a problem. Yeah, I feel like this should not be a expression too complex error. Well, I mean, it could be. It could be both. It could be both at the same time. But I think what I need to do here now is okay, so I'm going to store those things there. I could do it with an X, X, X. So we're gonna say if we get just a new line in the middle of an expression when we should not have one, then we're going to return that as an expression with a value of 0. And print out an error message, perhaps. And this would be a, basically this can only happen if you're inside a parenthesized expression, right? Because, well, no, that's not even true, right? If I could have like a 3 plus, and that's an error. We don't expect a new line there. I mean, it's a syntax error. We could just call it syntax error, right? Syntax error and expression. Okay, syntax error in expression. JSR error. All right, so what are we doing now? We're rolling back the stack. That's what this part does. We put a 0 in expression value and a 1 in expression type. We print out syntax error in expression and then return. And then because we did this, we're going to return to the expr subroutine. Here. We're going to turn right here. And then we would also, if the expression is also too complex, we'll print out that error as well. And then we'll return from the expression expr subroutine. Okay, that kind of makes sense to me. Now, I just have to find the situation where, okay, this is all fixing up the crash the stack thing. So this is not actually, maybe should not be fix x3. Well, I'll just leave the label as is for now. But this label could be also, we could jump to this label also, even if we don't have an expression which is too complex, where we suddenly have a new line in the middle of our right? Where specifically in the case of a new line, I mean. So here we have a terminal, we're looking for a terminal. We see, okay, is it a number? Yes. This is name, good. For label, backward label reference. Left parenthesis, good, we're going to do that. Otherwise, we unscan it and say it's a syntax error. But we need to handle things differently, I think, if it's a new line here or end of file or something like that, right? Then that's a different situation. So, I wonder if is this label used anywhere? Term x0? Term x0. Okay, it is. Oh, I see. That's when we expect to get a right parenthesis and we don't. We get a term x0. Okay. Okay. But in this case, it unscans. And in this case, it doesn't unscan. Right? It just, because it goes to term x0, so it consumes the right parenthesis. Oh, it consumes whatever is not a right parenthesis, I should say. Yeah, I don't think that's what we want. Instead, we've gotten something here. So if this is an EOF, then we actually can go straight down here to fix x3. But we can't go there directly because it's too far to branch there directly. So let's go to term x0, 1, 2, 3, 4, 5, 6, 7, 8. We've got a lot of them. I'll just call it term EOS. Yeah, okay. If it is end of statement, term EOS. If it is a comma, term EOS. Yeah, and I'm pretty sure that's those are the three. Those are the possibilities you'd have to go down here. Those will just go to fix x3. They can jump straight down there because we can't move past this end of statement type thing, right? So what that's going to do is it's going to go down there. It's going to roll back the stack, print syntax error, and so on. Okay. Now, if it is an unexpected token, which is not one of these things, then in that case, perhaps we want to try to see if we can somehow recover. Because we're not, I mean, when we have an end of line or end of file, there's no way we can continue. We've got to say this expression is done, no matter what, right? But if not, then perhaps what we ought to do is just go ahead. Well, one possibility is just to go ahead and collect tokens until we actually get into EOF, end of statement, comma. That might be a good idea. That might be a good idea. Just thinking, in other words, we give up on trying to get a statement. We just collect tokens till we get to and we give up on trying to parse the expression. We collect tokens till we get something which, the thing is, ideally we would collect tokens until we're sure that the statement is finished and then don't collect any tokens after that. But that's difficult. The only real way to do that is to keep parsing. But the problem is we've gotten something that makes it look like we can't keep parsing. So what do we have an option of, I just thinking that the thing we probably ought to do is just collect tokens until we get something which is the end of a statement. JSR scan, jump term x0. Okay, and we don't need that. And the reason I think that's okay is because I'm just trying to think, is there ever a situation in the assembly language that we're going to accept that you have a valid expression followed by something which is not an end of statement, like a comma? That's perfectly good. A comma is end of statement, a new line end of statement. End of file is, of course, the end of a statement. But is there a valid situation where you could have an expression followed by something which is not an expression? So that's not what we're talking about. Not part of a valid expression, but is somehow a part of a valid statement. And I don't think so. I don't think there is. Right? I mean, there are cases where you can have an expression inside an instruction. That's fine. But the thing is when you're finished with that expression here, you're also at the end of the statement. Right? Ah, well, okay, here's a situation. You could actually have, like, think of a thing like this. This kind of thing here, right? Array is a label. It refers to some memory, and then you're going to index it with X. Well, what if this array actually is an expression, right? And what if I wanted to say, array plus 2X? This is definitely an expression, and that's all fine. But there's a comma there. So as far as the expression parser is concerned, I mean, this comma is not actually the end of the statement by any means, but when the expression parser sees that comma, it's going to say, aha, it's the end of a statement, and it'll exit. So that's fine, right? So if you had something like this, for example, it's going to come here and it's say, oh, it's a syntax error, but look, it's the end of a statement, so we're all fine. So I think that will be fine. Anything else? We can have an expression followed by something else, which is not a comma, a new line, and end of file, but it's still valid. I can't think of anything right off the top of my head. Maybe I'm wrong, but let's just say I don't think so. So I think that's good. So anytime we get a syntax error, we're just gonna look at tokens until we get end of statement, that is end of line, end of file, comma. Once we get that, we're going to jump to term x. We're going to jump to fix x3, which will then restore our stack to wipe away anything we have as part of the expression parsing, and it will put a 0 in the expression value. It will put a 1 in the expression type. It'll print out a syntax error message and then return. And then if the expression was also too complex, that will print out an expression too complex message. That's a separate issue though. So I think that looks good to me, right? These to-dos are not errors issues, so that's all fine. Okay. So to me, I think there's one issue that I still want to do before I forget about, which maybe will be in the next installment, I guess, which is this thing, because I did it in the last installment 22, about the forward and backward labels. Those have to be checked because I took out the check in the scanner. And let me save that. And I think it's in AS1. Yeah, there it is. So basically, these things, forward label and backward label, need to check that number and make sure that it's a valid number, that it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If it's not, it needs to pretend like it's an undefined label. But I think that will be for next time. So until then.